is Aaron, and I'm going to walk through the Secret Mutant Hero Team Map Lab. So once you've accepted your assignment, you have your repo. Let's go ahead and clone that. So click this. If you select that, it automatically puts it in your buffer. Move over to your GitHub client, and we're going to clone this repo. Under the URL, you're going to specify the URL that you just copied, clone it. The first thing we'll do is we're going to create a new branch because we don't want to do our work on the master branch. We're following the GitHub branch and merge flow. So let's create a new branch. It's called Turtles. Create that branch. Now all of our work will be published in that branch. So what do we need to do for this lab? Well, we're looking for highest density of turtles in Tucson based on neighborhood association. So the city of Tucson has these two data sets that we're going to use, manholes and neighborhood associations, and they publish them as services through APIs as well. Some of you have, I think on Windows, are having trouble with the URL or having QGIS read the URL. So you just download that and add it as a static vector layer. That's fine. Oops. All right, so what we're going to do is we're going to add vector layer. Make sure the protocol is HTTP, GeoJSON, paste that URL in there. And that's going to load up the manhole covers. So actually these are the outlines of the manhole covers, and they're very small, and they are lines. So these are actually lines. So we ultimately are going to want to count the density of these by area. So we're going to actually do a count. So we're going to want points. We're going to count points. So we'll need to do some conversions, but we'll get to that. Let's add the other data. Neighborhood associations. Again, add layer, vector layer. It's already set to GeoJSON from before. We add that, and that's going to load up the neighborhoods. Okay, now that's loaded up, let's just take a look at the data for a sec. Zoom out to the full extent here of that layer. The neighborhoods, of course, are on top of the manhole covers. We're going to want to go the other way, even though we can barely see them. If you're really clever, you can kind of see some of them, but in any case, when I created this lab, I wanted to do it a certain way. I had a certain workflow in mind, and since then I've found two shortcuts that are going to make our life much simpler. And because we are wanting to be efficient, I'll show you the efficient way with the shortcut first, and then I'll show you the way that I wanted to do it. And I'll point out why we're doing the shortcut. So first of all, these data are in EPSG 4326, which you may be familiar with or you may not be familiar with, but it's a latitude, longitude coordinate reference system, and the units are degrees, so they're angles. In a reference system like that, when you do measurements and areas, they don't really make sense to talk about square degrees. So historically, you would have to transform or project those data to a metric reference system, something with feet, something with meters. Then you'll do your area calculations. It looks like, and I'm not sure when this happened, but currently you can actually do a calculation and it will do a geographic area. It's not, I don't think it's based on the sphere, so it's not going to be quite as accurate, but it will actually, you'll be able to do the calculation to area from this coordinate reference system without reprojecting it to UTM. So that's the first trick. The second trick is that we actually don't have to calculate area because the city of Tucson has provided it for us as an attribute. This is the attribute table for the neighborhood associations, and you'll see that there is a shape ST area. So let's see, let's take a look at this. Yeah, okay. So it's not clear. I mean, we can go back and look at the metadata, and that's what we should do. But just from the attribute table, it's not clear what the units are on that. For our purposes, we want to know basically a ranking of the neighborhoods that have the highest density of manholes to the lowest. So technically it wouldn't matter, but we should figure it out. I mentioned that we could actually calculate the area, and I actually did this. So let's calculate the area here. We're going to create a new field. It turns out I already created one, so let's just overwrite that one. It's going to be a decimal, and the precision at 10 and 3. So this is going to be 3 digits of precision with 10 digits of possibility. So that would be, you know, like 5591.734 or something like that. Under these expressions, we have all of these helper functions. One of them is area. So we calculate area. We'll call it area 3 just to show you that it's the same calculation as what we did before. And you'll notice, so this is area 3. So it's the same thing here, but you'll notice that these are actually different. So in this case, it's 10,313,965, and in this case, it's 958,184. And so it turns out, do that calculation, it's 10.7, which is the same conversion from 1 meter to square feet. So 10.76 square feet are in a square meter. So it looks like the city of Tucson has saved their area in square feet. So those are the 2 tricks I wanted to show you. Now, at this point, we may be able to do the spatial joins. So if you go into your processing toolbox and look under the general vector, you see the joins. There are a few different options. The one we want is the summary, because we want to do a count of the manhole cover points by area. So this is where we get to another trick, which is I originally intended that you would convert these manhole cover lines to points. And to do that, you would first close the polygon, do a polygonize, and create a polygon, and then take the centroid of that polygon, and then you have a points, and then you can do the spatial join with the points layer. But it turns out that the feature of lines would also work. So let's do that. All right, so let's join the attribute select by location. So our input layer is going to be the polygon layer. That's what our target for summarizing is going to be. The join layer is going to be the manhole lines layer. Since each line is its own feature, when we do the summary, we should get the right numbers. So we're actually not going to summarize any fields. We're going to do a count of the features. And let's create a new layer. Save this to a file. We'll call it neighborhood manhole density. And we run. What's interesting about this is when we look at the attribute table, you'll see that it actually creates a summary for every input field. Now they're going to be duplicated, but so you see that in this case, this feature has 74. Zoom in there, you'll see that it's pretty dense. So there's a bunch of manhole covers there. So that's great. We've kind of shortcutted a lot. So that's not the answer. That's just the count. So let's go back to our attribute table. Okay, remember we want the density, so we want points per area. So we have all of these points. This is the counts. And notice that they're named like handle count, handle COU, layer COUN, etc. Let's open up the field calculator. We're going to create a new field, and it's going to be a decimal. So this is really important. Call it manhole density. And for the expression, we're going to use the calculated field, area 2, and we're going to use, say, handle count. So it's going to be handle count divided by area 2. Now, let's look at those fields here. You'll notice that each of the fields has a little symbol next to it. In this case, object ID is 123. Object ID 123. 123 refers to it being a whole number. So unfortunately, or something to be aware of is, as an integer, if you try to multiply it times a real number, you will lose the precision, and it will just either it won't work or it will become an integer. Actually, I think it'll just become an integer. In any case, if we look what we were going to do here, the counts are all 1, 2, 3s, so we're going to have to convert those. But let's go ahead and set up the equation. So it's going to be the count divided by the area. Another thing to notice is only going to update the selected features. We don't want that. That was almost a grave mistake. So we're going to update everything. And if we do that, actually looks like it's going to work. So let's just try it out. Oh, real quick, the number is going to be something like 74 divided by 878,000. That's a very small number. So we just need to make sure that the precision is enough. So 10 digits is going to be enough. 3 decimals is probably going to be enough as well. So let's just make it 4 just for fun. All right, if we click OK, it's going to create the field, calculate it, and it's all zeros. So no good, no good at all. That's because we didn't cast it. So if we go back, let's update that same field. And this was our formula before. We need to do a conversion. So if you look at the conversions, we have to convert it to a real. So 2 underscore real, just like that. And it does some auto calculation for us. So let's do that. It's still not enough. Oh, our precision's not enough. Create a new field, make it a decimal, and let's give it all the precision it wants. Another name, dense2. And they made that same mistake where it's only updating the features that we want. So you can see this can be really annoying. So it's better to deselect before you do this. Otherwise, if you're in a loop like I am, then you keep making mistakes. You can update that existing field that we just created with the 10 precision. And now we have numbers that look like numbers. Okay, let's close this sucker. Zoom out. Okay, we're done editing this. Yeah, let's save it. Now let's take a look. Oh, actually, let's deselect what we have here. Okay, now we're going to symbolize it. And we're going to symbolize it as a graduated based on the density. And I said any gradient will do. Let's do blue to green. So the greener you are, the more likely you're going to find turtles. Now we need to classify them. So when we click classify, it's going to look at the histogram of the values in this field, and it's going to break them up based on whatever mode we selected here. So equal interval is fine. And I said 10 classes, so up it to 10, and okay. So blue is low density, green is high density. So big surprise, downtown we have more manholes, but there are these other areas here that have quite a few manholes. So that's that. The other strategies that I wanted to talk to you about that I originally intended was the main was, I guess, with respect to projections, we would export everything into the EPSG 102206, and the way you do that is you set the project coordinate reference system to what you want it to be. So here now we're in the UTM zone 12, and then we would be exporting our data. So export save features as, so this is the neighborhoods. So we say neighborhoods UTM, and then we select the project CRS, and we do that for both of the layers. Then we would basically have copies of the layers locally in this case, so we would save this to our I would save it here in my own data directory, and it would be in the UTM. Okay, I'm not going to go through with that. You can imagine how that's going to go. Both of these end up being in that, and then we calculate the area, and everything's hunky-dory. Okay, the other thing that I wanted to go through was specific to converting these lines to points. Let's go ahead and zoom in on some. All right, so these are lines, and what I had intended and what I wrote on the instructions was that we would take this, polygonize it, and can then convert it to points using the centroids. So in the toolbox, under the vector geometry, I believe. Yeah, vector geometry is polygonize. So these lines, for now I'm just going to do a temporary layer here. Since they actually have a good topology, they end up becoming lines or polygons, and then from there we can do centroids, and again we'll use the native vector geometry function, polygons from lines. So that was the one that we just created as the input layer. We want to find the centroids of those, and for now let's just make it a temporary layer. And that's that. So now we have points. So, and from here, it was going to be a join attributes by location using the neighborhoods and the centroids. And if we do that, you can see we have a single attribute. oops, forgot to do the summary, sorry about that. Move layer. All right, join attributes by location, use the main neighborhoods, and then we have to do the count. Now we look at the open attribute table. And there's no count. We want density, which is going to be count per area. And we have a count field for every input field here. Let's go to the field calculator. We're going to create a new field. Let's call it image density. And we want the output field to be a decimal. Now the numbers are going to be very small since we're looking at counts like 3 to a few hundred manholes per hundreds of thousands of square meters, or over 1 million square meters. So let's give the precision, make it 10 with output field 10 will be fine. And if it doesn't work for you, then you can play around with that until you get the right numbers, or read the documents and understand why. So the expression is going to be a field, a count field. So we have a bunch of count fields. So in here, let's do object ID count. And you'll notice that it says 1, 2, 3 beside it. That's because it's a whole number. It's an integer. And when we do a calculation with it, it's going to become, it's going to make the output also a whole number. So we're going to have to convert that to a real number. But in any case, while we're here, let's grab the area. So the area is a decimal, see 1.2. If you scroll up, you'll see that there are some conversion operations here. So there's to real. And so it takes a string. It'll also take a number and convert it to a real number. So to real. And then this is the value for our calculation. And then we're going to OK and go. So when we do that, we get numbers, good numbers. Let's take a look here. And I secretly stopped this video and got the answer, so let's just ignore that. So here we have our joined layer. We're going to convert the symbology to a graduated based on the density column. So here's the density column, and we wanted 10 classes. So if these numbers don't show up, you can just click this classify button and it will reclassify the intervals based on a histogram, which are very, very, very small, into classes based on whatever algorithm is specified here. Equal interval makes the most, it's kind of the most intuitive. It's going to be like if you have 10 classes, and you split it from 0 to 100, the first class is going to be 0 to 10, the second is going to be 10 to 20, etc. Okay, and we wanted to change this color from red. Let's call it red to blue, or dark green. We'll do dark green. Oops, this should be dark green here. And this will make it, light green. And OK, and OK. So the greener you are, the more turtles you're likely to get based on the manhole density. That's the gist here. So this is what I'm looking for. A map that looks something like that. OK, well, that pretty much concludes this. I will pause that.